Good morning. We will start session 8 on chapter pair of linear equations in two variables. We started yesterday with optional exercise. We had left one main in that which we will be covering today. I had given you all one graph homework as well. I had given you all few numericals, that is verbal problems where the algebraic expression we had framed and remaining you were supposed to do it at home. So the last main we completed and there we complete the chapter pair of linear equations in two variables. So seventh main, first one, the equation is given as px plus qy is equal to p minus q, qx minus py is equal to p plus q. Now look at the term here. We have 1 plus and 1 minus, so it is best we can eliminate this. So what we will do, we'll multiply, we have q and we have p, so we'll multiply this by p and we'll multiply this by q, right? So we'll reframe the equation now. P square x plus pqy is equal to, shall I multiply and write p square minus pq, okay, this one. Q square x plus, sorry, it is minus there, minus pqy is equal to pq plus q square. Understood? I multiplied monomial with binomial, otherwise one more step I have to show for multiplication. P into p square minus pq, q into pq plus q into q square. We are going to add the equation since we already have 1 plus and 1 minus sign. Plus pqy minus pqy will get cancelled. What about here? I will take x common. P square plus q square is equal to, add this, p square minus pq plus pq plus q square. Plus pq minus pq will get cancelled. X is equal to, multiplication comes division, what remain here? P square plus q square divided by p square plus q square, cancel, is equal to 1. Therefore x value is 1. Now let's find out y value. Substitute. X is equal to 1. In which equation do you want? Shall we take first one? Okay, in equation 1. So x is equal to 1. We'll write the equation first. Px plus qy is equal to p minus q. So x value is 1. P plus qy is equal to p minus q. Qy is equal to p minus q minus p plus p minus p. Y is equal to minus q upon plus q minus, so is equal to minus 1. Therefore, what is y value? Y value is minus 1. X value is 1 and y value is 1. Similarly, we'll start with the next one. First one was quite very simple. All the sums are simple here, but the steps becomes very lengthy when we multiply with it. Okay, quickly we'll begin with second one. Second one is bit lengthy because we will not get a perfect whole numbers there. We get that in terms of A, B and C. So that term only we have to substitute to get x or y. Seventh one, second sub question. Ax plus by is equal to c and bx plus ay is equal to 1 plus c. Now what we will do here, shall we eliminate x term here first or you want to eliminate y term? So we'll eliminate y term here. If you want to eliminate y term, with what you want to multiply, that you should know first. So if I want to eliminate anything, you can also eliminate x term, children, or you can eliminate y term also, up to you. So if I want to eliminate y term here, I have to multiply this by a is there, b is there. this into A and this into B. Okay. So after this we get this as, okay, this is equation 1 and this is equation 2. So this is a square x plus aby is equal to AC. Here b square x plus aby is equal to binomial by monomial. What do we get? We get b plus bc. Okay. Let us subtract it. Minus, minus and minus. So plus aby minus aby will get cancelled. What will remain here? A square x minus b square x is equal to AC minus BC minus B. I just wrote BC first and then there is no difference. Okay, this is our term. Now y term is eliminated. We have to find x. Take x common. What do you have? A square minus b square is equal to, what best you can take common? Not in the whole, at least in the part. I can take common here as c. What will remain? A minus b. Understood why I took bc first and then this? Minus b as it is. Okay. That's the final answer actually. X is equal to c as it is. A minus b of minus b divided by a square minus b square. Children, this is your x value. Right? This is what you have to substitute in the given equation now to find y. So, x value what we have got as c of a minus b of a square minus b square. Let us substitute this in any of the equation to find y. Substitute x value, I will write, I will not repeat it again. X value in equation, I think 1 is very simple enough. In equation 1 we will simplify. I will just write the equation here. Ax plus by is equal to c. I will substitute this side, children. Ax plus by is equal to c. X value, I will keep a as it is. What is x? That is nothing but c of a minus b of a square minus b square plus by is equal to c. Right? Now what we will do here is, this is x value and that is c. So did I do it correctly? Yes. Now we will keep this, first finish multiplying the part and all, and then we will see what best we can do with it. Or directly what we can do is transpose it to that side. by is equal to c minus, and what transpose this one term to other side. Okay, minus a of, I'll multiply this, ac minus bc minus b as it is, divided by a square minus b square. Understood, children, what I have done? I kept by as it is, c as it is after equal to sign. The whole this I took it as minus there. Okay, assume that this was one single number. If I take it minus, I will get the same thing I got. I multiplied AC minus BC minus B as it is, divided by a square minus b square. Let me take a square minus b square as a LCM. by is equal to, so if I multiply this, a square c minus b square c minus a square c minus minus plus abc minus minus plus ab whole divided by a square minus b square. I repeat, I have taken LCM, that means this is nothing but by 1. This has to be multiplied here. A square minus b square. That is what I have done. A square c minus b square c. Minus sign as it is. A into AC, a square c. Minus into minus plus ABC. Minus into minus plus AB. Okay. Next step. by is equal to See what you can cancel. I think plus AC square minus AC square can be cancelled. What remained? Minus B square C plus ABC plus AB divided by A square minus B square. Okay, what we can take common here? So we will take B as common. By is equal to, if I take B common, so this is minus BC plus AC plus A divided by A square minus B square. This B and this B will get cancelled. Okay. Now final thing what we have to write here is, now this is also in the form of A square minus B square. Let me see with what I can take common here. Okay. Now next, Y is equal to, between this what is common? BC and AC. C is common. Okay. C is common. Can I write this as A minus B? C into A, AC. C into minus B. I got the same thing. Plus A divided by A square minus B square. So that's the answer. This is your X term and that is your Y term. That is what I told you. You will not get as whole numbers as answer, wherein you will get that as in terms of A, B and C. Copy this down. So the next one we will start, which is x by a minus y by b is equal to 0 and ax plus by is equal to a square plus b square. We cannot be solving this directly, and remember, if you look at this, it is not of equations reducing to reducible form. Why? Because denominators are not variables, they are constants. We already have the variables in the numerators. That means we have to rearrange or rewrite the first equation, which we will do that. From equation 1, x by a minus y by b is equal to 0. Let me transpose it to other side. X by a is equal to y by b. Cross multiply. Bx is equal to ay. Right? Now how do we know that? I had to solve it by this method only, by transposing, then cross multiplying. That comes by practice. That means you need to solve number of sums based on this worked examples, exercise, assignments what I have given, or through any other sources. By practice you will have an idea how to start or how to deal with the given sum. So bx is equal to ay. Now transpose it to this side. It is bx minus ay is equal to 0. This is your equation 3. Now we are going to solve equation 2 and 3, not 1, because this 1 we interchanged it as like this. Now below this write equation 2, ax plus by is equal to a square plus b square, which is your equation 2. To equalize this, we can cancel y term. I have minus ay plus by. So here I can multiply this by b and multiply this by a. So do the multiplication. So b into b, it is b square x minus aby is equal to 0. A square x plus aby is equal to a of a square plus b square. Add the equation. This and this will get cancelled. What will remain? I'll take x common. A square plus b square is equal to a of a square plus b square. Next step. X is equal to a of a square plus b square divided by a square plus b square. Both will get cancelled. So what will remain? X is equal to a. This is the answer for x. Let me check for y. Which one you want to substitute? This is your equation. These two are your equations. Substitute. X is equal to a. In equation 3 shall we take? Yes. Equation 3. Equation 3 is bx minus ay is equal to 0. So b into a is ab minus ay is equal to 0. So what will I do now? Minus ay is equal to minus ab. Y is equal to minus AB divided by minus A. Minus A will get cancelled. What will remain? Y is equal to B. X is equal to A and Y is equal to B. Quickly, we'll start with the fourth one. Read the fourth question and decide or assume that what you have to actually do with the given equation. Directly you have to start it, or you have to change any equation 1 or 2 in some different form. Let's see. Fourth one. A minus p of x plus a plus p of y is equal to a square minus 2ab minus b square. A minus b of x plus a plus b of y is equal to a square minus 2ab minus b square. Children, this is not a minus b whole square because we have minus b square. So keep it as it is. Another equation, this is equation 1. Another equation, a plus b of x plus y is equal to a square plus b square. Now this is a product what is being given. So let's change this. It is a multiplication of a binomial with binomial, right? So let us rewrite this equation as multiply x with a plus b of x plus then a plus b of y. What did we do? Instead of writing here, I have written here. I have simplified by binomial multiplication. Distributive property I have applied it to spread that equation. Right? Keep it as it is. Equal to a square plus b square equation 2. Yes, children? Now it is very clear what we have done. So it is easy for us to cancel also. What shall we cancel here? Of course, y we can cancel because a plus b of y, a plus b of y. That means equation 1 and 2 we need to subtract it. You have to rewrite the equation. I am not writing it again. Minus, minus and minus. Be very careful when a binomial is there and you are using the minus sign. Write the first equation. It is a minus b of x minus x of a plus b. Both are same. Writing here on that side. A plus b of y minus a plus b of y will get cancelled. Write that first. A square minus 2ab minus b square minus a square minus b square. Be very careful when minus sign is there and a binomial we have. Okay. Now split it. This can be written as ax minus bx minus ax minus bx, a into x, x into b minus bx minus ax minus bx is equal to plus a square minus a square cancel minus 2ab minus 2b square minus ax plus ax cancel minus 2bx is equal to shall I take minus 2 common? What will remain? AB or okay, I will take here minus 2b common. What will remain here? A plus b will remain. Minus 2b into a minus 2ab. Minus 2b into plus b minus 2b square. So minus 2b will get cancelled even if you bring it down. What is x value? X value is a plus b. Okay, now we have got x value as a plus b. Let me substitute and get y value. In which equation you want to substitute? Any equation. Let me take equation 2. Okay, substitute x is equal to a plus b in equation 2. So write second equation, a plus b of x plus a plus b of y is equal to a square plus b square. So after you write this a plus b of x, it is nothing but a plus b of a plus b plus a plus b of y is equal to a square plus b square, right? Let's simplify this further. I'll do it here, children. A plus b is written as a plus b whole square plus, we'll open the bracket or we'll keep it as it is, a plus b of y is equal to a square plus b square. Now what we will do here is we will transpose it, or we will first simplify. A square plus b square plus 2ab plus a plus b of y is equal to a square plus b square. Now we have to transpose it completely that side. A plus b of y here only is equal to a square plus b square. Transpose this, minus a square minus b square minus 2ab. A square, b square will get cancelled. Y is equal to minus 2ab of a plus b. This is your answer for y. So that is what we have. Some answers we get as whole numbers and some we get in the form of a and b or c, that we have to find. Last one, fifth one. Fifth sum, if you do, you will get an idea of several such sums where the given equations have a very high number, where addition and subtracting or by elimination directly will be very difficult. Let us understand what trick we use to eliminate x or y term there. Because to equalize, what we have to do to equalize x or y, usually we multiply it by a particular number, right? But here if you sit and multiply such big numbers, your whole, if the question is for 2 or 3 marks, you will require more than half an hour because you go on multiplying with such big numbers. So the trick is here. Fifth one, 152x minus 378y is equal to minus 74 minus 378x plus 152y is equal to minus 604. Equation 1, equation 2. Let me check. 152x minus 378y is equal to minus 74. Minus 378x plus 152y is equal to minus 604. So see, if you start equalizing this, multiply this by 152, multiply this by 378, not possible at all. Whenever you have such bigger numbers, first and foremost thing you have to either add them or subtract them and get fresh equations to eliminate. First we will write add the given equations. Okay, we'll rewrite once again. 152x minus 378y is equal to minus 74 minus 378x plus 152y is equal to minus 604. When you actually add them, so you get 2, because it is 1 is minus and 1 is plus, so you get 226x plus 226x, sorry, minus 226x here, because minus is the sign, minus, same thing it will be, 226y is equal to what what you get here when you actually have to subtract minus sign, but you add them. So you get minus 678. Okay. 226 if you take common here. Minus 226 if you take common. Minus 226 if you take common. X plus y is equal to minus 678. Bring this 226 down. X plus y is equal to 3. Equation 3. Isn't this equation very simple? We actually take a minus sign, subtract it here. Here also we subtract it. We are adding it, but that means minus sign is there, so subtract. Minus sign is there, subtract. Minus sign. Put the subtraction sign, but actually add. So you get this. Next one. Subtract the given equation. Okay, I'll do this side, children. So it is again 152x minus 378y is equal to minus 74. Minus 378x plus 152y is equal to minus 604. We actually subtract them. So change the sign, plus. So when you do that, plus you get 530x minus 530x. So 1 plus 1 minus is equal to 530. Very simple. So you want everything in terms of 530 only. Oh sorry children, 535, otherwise you will get 0 answer. 530x minus 530y is equal to 530. Now next what you will do, take 530 common. X minus y is equal to 1 is your equation 4. Now is it very simple to solve equation 3 and 4? So remember, whenever you have such bigger numbers, you need to actually first either add them or subtract them. You will get smaller equation. Even if it not in terms of x and y, 3x, 2y, 4x, 3y, something like that, then equalizing and eliminating will be very easy. So below this I will write x plus y is equal to 3. X minus y is equal to 1. You actually add them. 2x is equal to 4. X is equal to 2. So what's your next step? Substitute x is equal to 2 in equation. Whichever equation you want. Substitute x is equal to 2 in equation. Which one shall we take? 3 shall we take? So x plus y is equal to 3. 2 plus y is equal to 3. Y is equal to 3 minus 2, that is equal to 1. Y is equal to 1. So x is equal to 2 and y is equal to 1. With that, we complete the optional exercise of pair of linear equations in two variables. So we completed the chapter. The next chapter which I will be starting in my next session is quadratic equation, because I feel it's a continuation of this chapter. There are several sums here in linear equations which can also be solved in quadratic. Some numericals in quadratic, that is verbal sums, can also be solved in linear method. One more thing children, in the beginning of the class I had given number of ways or different types we can solve linear equations, right, by algebraic method. So number of methods I had listed down. It was like elimination method, substitution method, cross multiplication. You might have noticed I had mentioned one method of completing the square. Actually, it was my mistake. Method of completing the square will come in quadratic equation, not in linear equation, right? So we'll be doing method of completing the square in quadratic equation. By mistakenly, I had given that method there. Please strike it out. So with this we complete the chapter. Any doubt in today's class, you can call on the same day of the video set.